Hello, this is Mrs. Pullen again. It's Unit 4, Day 4, adding and subtracting rational expressions with different denominators. So back in elementary school, you learned to add fractions where the denominators were not the same. And the first step you needed to do is you needed to find the LCD, the least common denominator. In other words, what can both of these denominators go into evenly? And it turns out that it's 10. 5 can go into 10 twice, and 10 can go into 10 once. So the LCD is 10. You then went ahead and you created equivalent fractions. So 2/5, I needed the denominator to be 10, so I would multiply the numerator and denominator by 2/2. That's just a version of 1. So it changes the appearance of the fraction without its value. So when you multiply across, 2/5 is the same thing as 4/10. We didn't need to change the second denominator because the second fraction because the denominator was already 10. Once the denominators are the same, we can add the numerators and keep the denominators. In this particular case, I did not have to reduce the fraction. So I'm just going to go through a couple of examples here, not every single one. So let's look at example 2. I want to have a common denominator, so I know that the LCD is 6 because 3 can go into 6 twice and 2 can go into 6 3 times. So I'm going to rewrite each fraction just so I have room for you to see what I'm doing. And in order for me to have a denominator of 6 for the first fraction again, I need to multiply the numerator and denominator by 2. And for the second fraction, in order for that denominator to be 6, I have to multiply the numerator and denominator by 3. This becomes 12x on top, and this becomes 3. My denominators are now the same, so I can combine, or in this case, there's nothing to combine. I'm just going to rewrite. And I'm going to look to see if I can reduce. And you can either do the triplet thing and divide each term by 3, or you can factor out a 3. And I see that I can reduce 3 goes into 6 twice. So my final answer is 4x plus 1 over 2. And I'm going to box in my final answer. Okay, so let's do another problem. Let's say I want to do, let's go back. Let's do number 3. So in number 3, I want to have a common denominator. What can both 4a and 3a go into evenly? And it turns out that the LCD of this one is 12a. 4a can go into 12a 3 times, and 3a can go into 12a 4 times. Notice that it's not just the number that you're looking at, you have to look at the variable, and both of them can obviously go into a. So I'm going to rewrite the original problem just so you can see what you're doing. That extra step can save some time in the long run. And the goal is to have a common denominator of 12a. I'm going to switch pens. You may want to do the same. And what could I multiply 4a to get 12a? 3. Make sure you put parentheses around the numerator because you're going to have to distribute that 3 to both terms. And you get 6a plus 18. For the second fraction, in order for 3a to become 12a, I'm going to multiply the numerator and denominator by 4. I distribute, and I get 12a minus 8. My denominators are now the same, so therefore I can combine like terms. I get 18a. 18 minus 8 is positive 10. This can be reduced. You can either do the triplet thing and divide each term by 2, the 3 terms, or you can factor out a 2. The balance is 9a plus 5, and I can reduce the 2, and my final answer is 9a plus 5 over 6a. Don't forget that a that's over there. Can I cross off those a's? No, I'd be breaking up the family in the numerator. For number 4, the denominator is a little trickier to see. What is the LCD of 7 over x and 6 over x plus 5? Remember, x plus 5 we have to treat as a unit. And it turns out that the LCD is x times x plus 5. If you have trouble seeing it, let's see what happens if we did a number on the side. So we're just going to take a break here so you can see why the LCD is x times x plus 5. Suppose I said x was 2. Then we would have 7 over 2 plus 6 over 2 plus 5. Well, how would you get the LCD of that? Well, if it were numbers, you would go ahead and combine the 2 plus the 5 together to get 7. So what is the LCD of this? The LCD would be 7 times 2, or 14. How did we get it? We multiplied the denominator of the first times the denominator of the second. Notice there was nothing in common between those two. Likewise, for the variables, we're going to do the same thing. Don't forget, just because it looks like you have an x in common, it is not a common factor because the x plus 5 is a unit. So like before, we're going to rewrite the original problem, leaving a little bit of space so we can do some work. Again, you want to work neatly and very organized. And again, we said that the LCD is going to be x times x plus 5. Let's switch pens here. So what do I need to multiply this denominator by so I get x times x plus 5? In other words, what is our missing factor? And our missing factor is x plus 5. For the second problem, if you want x times x plus 5, what are we missing here? We're missing the x. When we distribute, you get 7x plus 35. And over here you get 6x. Just one point, don't go ahead and factor again and then try to reduce because you're going to end up with this original problem. You go ahead and when you're factoring and reducing, when you're adding and subtracting, that's the last stage. In any case, let's go back to finish up the problem. We now have one common denominator and we add our numerator. 7x plus 6x is 13x plus 35. We see we can't factor anything, we can't reduce anything. This is our final answer. I'm going to do problem number 8 right now. So for problem number 8, there's a bunch of things we have to look at. First of all, we have a watch out here. You see that negative? Watch out. You're going to have to be careful with that. And we notice that it's not so easy to find the LCD in this case. What you need to do for problems like 7 and 8 is you need to factor the denominator first. This is the only time you factor first when you're adding and subtracting, specifically to go ahead and find the LCD. So I'm factoring it, and by now we're proficient at factoring. And I'm going to write this as plus a negative 1. again, to remind yourself that we're distributing the negative as well. And we look to see what the LCD is. What can both denominators go into evenly? And it turns out it's b minus 4, b plus 3. b minus 4b plus 3 goes into this once, and b minus 4, if I divided it into it, I would be left with b plus 3. So we'd have no denominator if I did that. That's why this is the LCD of this problem. So I'm going to rewrite the first fraction because we need to make no changes for that. But for the second fraction, I need to find the equivalent fraction. So what am I going to multiply the numerator and denominator by? So it becomes b minus 4b plus 3. What's the missing factor? b plus 3. We now distribute that negative to both signs, and we get, both terms. You get negative b minus 3. Combine like terms. 2b minus b is b. Minus 1 minus 3 is minus 4. We're almost done with the problem. I now reduce common terms. Remember, it reduces to 1, not nothingness, but to 1, and we're going to put that on top. So we get 1 over b plus 3. And that's all I can do. One last problem. Let's do number 11. It's a little intimidating to students because a lot of students are a little confused how to factor when you have two variables. It's just like with one variable. So again, we have a watch out here. We're going to make sure that goes to plus and negative. So this way we don't make a careless error. We're going to factor the denominator. And it turns out that it's b minus c, b minus c. Remember, a negative times a negative is a positive, and if you were unsure of the inner and the outer term, that would be negative bc minus bc is negative 2bc. What do you think the LCD is? Put the tape on hold and see if you get it. Did you get b minus c times b minus c? That's great. So the first fraction I don't need to do anything with because the denominator is already what we want. But for the second fraction, we're going to multiply the numerator and denominator by b minus c. We carefully go ahead and distribute. Let me just write the denominator here. We distribute the negative b to both terms. We get negative b squared plus bc, or cb. I'm going to rewrite the denominator again. You can try not to do shortcuts. That's where students make mistakes, or teachers too. We go ahead and we can cancel the b squared minus b squared, and you're left with bc over b minus c times b minus c. And if you would like, you could write this as b minus c squared. That's my final answer. Good luck with everything.